So welcome everyone. This is Dr. Murali Sagar Varma, Associate Professor in the Department of Civil Engineering, MEGR College of Engineering. So today I'm going to give you a quick introduction to pre-engineered buildings, commonly known as PEB. We will cover what they are, their history, key components, advantages, types and applications, all in about just 5 minutes. I think this as a structured preview of a much deeper topic. Please also note that this is just a brief overview. A detailed explanation will be available in separate videos, which I'll be sharing with those who are interested, right, in the content. So just look at the content and let me know if you're interested so that I can share the full videos. Now here's what we will be walking through today. 8 key topics from the basic definition and historical evolution through to components, advantages, system types, applications, the design process and current market trends, so that this gives you a roadmap of the subject. So what exactly a PEB? Simply put in a simple sense, it is a building system where all structural components are designed and fabricated in a factory under controlled conditions and then transported to the site for quick assembly. Unlike conventional buildings, PEB systems use computer software to optimize steel use, resulting in a tapered members that place material only where the structure actually needs it. The outcome is a lightweight, cost-effective structure erected in days or weeks rather than months. This slide contains a visual illustration of PEB structure. Please take a moment to note the overall form, the tapered frames, the cladding panels, and the open column-free interior. These features visually capture everything we just discussed in the definition. PEB did not appear overnight. So let me just switch on the pointer so that you can focus on where I'm speaking. It has evolved over more than a century. The roots go back to the 1990s with the first prefabricated metal buildings. The World War II demanded in 1940s for accelerated prefabricated steel construction for military use. By the 1960s, the MBMA, which was Metal Building Manufacturers Association, that was founded, bringing standardization. The 1980s introduced CAD and computer-aided engineering. By 2000s, PEB has gone global into the Middle East, India, and Asia Pacific. Today in 2020, BIM integration, solar-ready roofs, and net zero design are reshaping the industry. The primary structure is the skeleton of a PEB. The main elements are primary rigid frames. Just 1 second. These are tapered welded eye sections that carry all the loads, and they're capable of having clear spans up to 90 meters. End wall frames, which are lighter frames at both ends, which you also call it as gable end frames, and they are designed to allow future building extension. The mezzanine floors, which are intermediate level, use it for offices or storage, fully integrated into the main frame analysis. And this visual shows a mezzanine floor with a PEB. Notice how the intermediate floor is neatly integrated to the primary frame without disrupting the column-free working space below. So you can identify various components in the PEB and how the structure looks like after erection. And this picture shows the mezzanine floor, generally provided for office space uses. Beyond the primary frame, secondary members complete the system. The purlins, girts, which are cold-formed Z-C sections that support roof and wall cladding respectively. And the eave studs sit at the critical roof wall junction. Bracing rods or cables handle lateral wind and seismic loads. For cladding, we have insulated sandwich panels for roofs, profiled metal wall sheets, transparent GRP panels for daylighting, and flashing for watertight junctions. Why choose PEB? The numbers speak very clearly, which I am showing here. The construction is 30 to 50% faster than conventional methods. Overall cost savings of 20 to 40%. The steel usage reduced by approximately 30% due to due to taper sections. The steel is 100% recyclable. Members are pre-punched and pre-drilled, so minimal skilled labor is needed on site. Quality is consistent thanks to factory conditions, and with clear spans of 90 meters or more, you get completely column-free interiors. Plus, the buildings can be expanded in future with minimal disruption. PEB is not one size fits all. There are several system types. Clear span rigid frames for column free interiors up to 90 meters span, which is the most common type. The multi-span frames for very wide buildings with interior columns. Single slope or mono pitch roofs for lean-to extensions. Truss rafter system for spans beyond 60 meters. The space frames for complex or irregular plans like airports, arenas, and multi-story PEB for stacked office for light industrial floors. And these images show three less common but important systems: the truss rafter system, space frame, multi-story PEB, along with the regularly used single span, double span, mono slope, multi-span PEB frames. PEB is remarkably versatile. It is used across warehouses and logistics centers, manufacturing plants, commercial showrooms and retail malls, aircraft hangars, which needs almost 40 to 90 meters clear spans, defense facilities for rapid deployment, agricultural stores, power utility buildings, and sports arenas. If you need speed, large open space, and cost efficiency, PEB is the answer. And the process flows in 6 clear steps. First, the client brief, gathering all building requirements. Then concept design, selecting frame type and layout. Step 3, there is structural analysis using finite element analysis software for all load cases. Step 4 is detail engineering, member sizing, connections and shop drawings. The step 5 is factory fabrications, which includes CNC cutting, automated welding and coating. Finally, the site erection. Frames are shipped with erection marks and assembled by crane. The PEB market was valued at approximately 17 billion US dollars in 2023 and is projected to reach 28 billion dollars by 2030, growing at a rate of 7.2%. Asia, particularly India, China, and Southeast Asia, is the fastest growing region. The key trends include BIM and digital twins, net zero carbon design, solar ready roofs, robotic welding, seismic resistant connections, and modular data center enclosures built with PEB shells. PEB has its limitations also, and it's very important to know them. It is economical only up to about 30 meters eave height. It works best for rectangular plans. The complex geometry adds cost. The fire rating requires intumescent coating since base steel weakens at 550 degrees centigrade. Very heavy crane loads about 50 tons push the design beyond standard PEB efficiency. Thermal bridging needs careful insulation detailing, and aggressive marine or chemical environment demands special protective coatings. Here I'm just showing you to understand better the difference between the conventional steel building and PEBs. So PEB is efficient, optimized sections having tapered cross-section members, where conventional buildings will have prismatic members. And this comparison table clearly highlights where PEB stands against construction. The design time is 2 to 4 weeks for PEB versus 8 to 16 weeks conventionally. The construction takes weeks to months instead of months to years. The PEB uses optimized tapered sections versus heavier uniform hot rolled sections. The quality control is consistent in the factory, and expandability is far easier PEB is the preferred choice for industrial, commercial, and logistics buildings. This is one of the most elegant concepts in PEB design. The frame profile, the varying depth of the rafter, which actually mirrors the shape of the building movement in shear force diagrams. This means the material is placed exactly where the structural demand is highest and reduced where the demand is low. This is the core reason PEB saves 30% more steel than conventional uniform sections. So this the visuals in the next slides brings together all components which I have discussed: the primary frames, secondary frames, cladding, bracing, assembled to complete PEB structure. So in the next coming slides, we are going to discuss other components. Here we see the actual factory manufacturing process for PEB mainframes. The steel plates of greater 45 degree 345 MPa are gas cut to precise profiles and then welded together using automated processes. This controlled environment is what guarantees dimensional accuracy and weld quality. The purlins and girts are made from cold formed steel, either jet section or C sections. An important feature is lapping, where purlin sections overlap at intermediate supports to create continuity, significantly increasing their load carrying capacity. The sag rods and sag angles provide lateral support to purlins and girts, preventing them from rotating or deflecting sideways under loads. The sag angles are cold formed, typically 45 by 30 by 2 mm size, and sag rods are solid bars of 12 mm diameter. These are simple component but very critical for stability to provide lateral resistance to the main members. The top flange of rafter is connected to purlins, giving lateral restraint, but the bottom flange is free and can buckle under compression from bending. The flange bracings are diagonal members connecting the bottom flange to the purlin above, preventing this torsion buckling. This is a PEB specific detailing requirement that is essential for the SAFR behavior. The base plates connect the column to foundation. There are two types. A pinned base uses bolt between the flanges, resists axial and shear force only. It requires minimum of 4 bolts and suits low wind and crane loads in buildings under 10 meters height. It is economical. A fixed base uses bolts inside and outside the flanges, resist moment, axial and shear forces, and that needs minimum of 8 bolts and is used for tall buildings or high wind or and crane loads. It requires heavier, more expensive foundation. The bracing system is what keeps the PEB stable under lateral loads, wind, seismic and crane forces. Mostly these will cause lateral loads. The bracing transfers these forces safely to the foundations. The 4 types are rod bracing, angle bracing, tube bracing and throttle bracing. And this classification is based on the type of member used in the bracing system. And the choice depends on the magnitude of lateral forces and the architectural requirements of the building. To wrap up, PEB is a factory-made, site-assembled, optimized steel building system. It offers up to 30% steel savings, 30 to 50% faster construction, and is ideal for warehouses, factories, hangars, and commercial buildings. The clear spans of up to 90 meters create fully flexible column-free interiors. The global market is growing at 7%, with Asia Pacific leading, and BIM, green design, and automation are shaping its future. Thank you for watching this overview. Thank you.